Okay. So after the metal and semiconductor has been brought into contact, once you make a contact with the metal and semiconductor, you know the electrons will start to flow from the semiconductor into the metal, and as a result, the depletion region of width XD with uncompensated donors is formed. So same as how do you when you make P and N regions to make a contact, you have the immediate realignment of the charge carriers take place across both sides, forming depletion barrier, right? Depletion region, right? So same thing is going to happen here. So after the metal and semiconductor has been brought into contact, the electrons will flow from semiconductor to the metal, and as a result, the depletion region of width XD is formed. Okay, you will have alternating positive and negative charges across the depletion region on both sides. Electrons continue to flow into the metal till the Fermi level becomes same. So you can see here the Fermi level of the metal is at the bottom and the Fermi level of semiconductor is at the top. So naturally, you know the flow of electrons will be from higher energy band to lower energy band. Okay, so the electrons will be flowing from semiconductor into the metal. Okay, so even though metals are going to have a larger number of free electrons, since a barrier potential is existing between the Fermi level of semiconductors and the Fermi level of metal, so the electrons will continue to flow from semiconductor to the metal until the Fermi level becomes same, until the Fermi level of the metal becomes equal to the Fermi level of the semiconductor. That is what is told here. So in metal, the electron's current forms a negative surface charge layer. This results in electric field and the band edges are lower in the semiconductor shown. So because of barrier potential or depletion region being formed, there exists a strong electric field across the metal semiconductor junction. Everything is going to be same. Whatever we have studied, metal oxide semiconductor device or a normal PN junction diode, wherever you are going to have a contact made, you are going to have a barrier potential or the depletion region being developed. So the depletion region will have a specific width and the depletion region will have a specific voltage. But here, because of the electrometal semiconductor junction, since the semiconductor junction has a higher Fermi level compared to metal, the electron flow is going to happen from the semiconductor to the metal as we thought the other way. Because metals have a lot of free electrons, we thought metal will supply the electrons to semiconductor. No, the semiconductors are going to supply the electrons to metal till the Fermi level becomes same. Okay, that is what is told here. And because of the flow of current, you have a strong electric field developed across the device, and that is going to lower the band edges of the metal and semiconductor region. So see here, so until the Fermi level becomes, see here, this is the Fermi level of your metal, this is the Fermi level of your semiconductor. So until the Fermi level becomes same, you have a strong current flow happening across the device, and you can see the band edges are slightly reduced from their actual value because of the strong electric field which is present across the metal semiconductor junction. So you see a lot of negative charge here and you see a lot of positive charge here. So these two charges are formed across the depletion region of the device, leading to a strong electric field. This electric field results in reduction of energy band in the semiconductor side, not in the metal side. And current flow happens until the Fermi level of the metal, EFM, is equal to the Fermi level of the semiconductor region, EFM equal to EF. Okay. So these are the different combinations of metal and semiconductor junctions which they have found, and they have got the value for work function and affinity. So metals, aluminum, for metal, aluminum, the work function is 4.28. For silver, it is 4.26. For gold, you see it is very high, 5.1. Chromium, 4.5. Nickel, 5.15. Even more higher. Platinum, very high, 5.65. Titanium and tungsten. So these are three of them have a very high work function value. And the electron affinity, silicon 4.01, germanium has a higher affinity 4.13, gallium arsenide 4.07. Affinity means how the metals are able to attract the electrons from semiconductor. or whether the electrons are really having a willingness to travel from the semiconductor to the metal layer if a contact is made. So these are the different metals and semiconductor values given. So you can choose between them. You can choose any combination of this metal semiconductor combination, and you can make a contact and fabricate your devices. Okay, so you can make a contact and fabricate your device.